Hello everyone. Today we'll see what is OAuth and OAuth Flow with PKCE and OAuth roles. So OAuth is a open standard authorization protocol which authorizes application access without username and password. Users access token for authorization. So it didn't need the plain that application don't want to send the username and password in that to get that authorization. Instead, it uses access token and refresh token for this authorization. So OAuth 2 is completely rewritten of OAuth 1 and not backward compatible. So consider a scenario. So OAuth, if you were we are using OAuth. So if you want to have access, give access to third-party application from Facebook or Google identity. So we have an identity in Facebook or Google, and if you want to give access to the third-party application to access this app-to-app authorization to access Google or Facebook identities, so that the user don't want to send the username and password to the third-party application. So it's a more secure way of doing authorization. So here we'll see what's the difference between OAuth 1 and OAuth 2. So OAuth 1 is basically it won't supports it only supports web client application. It won't supports mobile or native application. And OAuth 2 supports multiple clients types like web, desktop, and mobile application. And the complexity in signing, if you see, the OAuth 1 needs to generate a signature for on every API calls. So it's a kind of complex OAuth authorization flow. And in OAuth 2, it do not need to generate signature, but uses HTTP SSL for to establish a secure communication. And OAuth, no, OAuth don't have separate roles for this uh, activities. So it only has a consumer and service provider and a user, and it don't have the separation of roles. But in OAuth 2, it has a separation of roles such as client resource owner, and authorization server, so that the implementation and the development and the it easy to implement, and it's not that much complex as OAuth 1 in implementation. And OAuth 1 uses a access token, which is valid for more than a year. But in OAuth 2, the access token is here we have a refresh token. So the access token is a short-lived, and we use a refresh token is a long-lived refresh token. So through refresh token, we can get that access token without establishing these. Without reauthorization is not needed, since we have that refresh token. Through refresh token we can get the access token, so that it simplifies that authorization workflow in OAuth 2. So we'll see the roles of OAuth roles here. So OAuth roles, we have a resource owner. The resource owner is the one who authorizes the application to access their account. So the application, the what under the application access to the user account is limited to the scope of the authorization grant. So here the grant is a read or write or full control what the grant we are giving. So the resource owner is a separate entity, so which taken care this user authorization of the application account. And client is the application that wants to access the user account. So this is a client application, so which it wants to access the identity for this authorization. And resource server is a host, is protector. The resource server is a host that contains a user accounts and identity information details. So authorization server is a validation server which verifies the identity of users and issues as access token and to the application. So we'll see the much more detail in the coming slide about the roles. So this is the authorization workflow. So here we have a resource owner is a below one. So resource owner is trying to access the client application. That's a third party application. So once it access, it tries to talk to the authorization server. So here that authentication happened in the authorization server. So the user to login pop-ups comes, and then the user authenticate that authorization server, and then it need to consent. So what are the role? What are the scope it want to access, like a read, write, or full control, or depends on the authorization server scope, we need to give consenting. Once the consenting happens, then it gives us authorization code. The application gets that third-party application gets that authorization code and the access token. Then it can access the resource server using the access token. So this is a simplified OAuth roles, and the communication flow happens in this way. So here we have in OAuth we have two types of clients. So it's a confidential client and public client. So confidential client is one which has the application is a secure authentication with the authorization environment. So it's in the sense it can able to protect that access token and reference token within the client itself, and it can't able to any that it can't able to expose to outsiders. So a simple example is a native client. So if you have a desktop application, that is considered as a confidential client because the token we can securely store in that application itself. The public client is a sense it's can't able to store the client secrets, such as browser application, mobile device. So apps and mobile apps and browser which browser web single page application, they can't able to protect the secret client secrets like access token and reference token. So that we need to find a way to protect that client secret in a much protected way. So that's a public client. So we'll see how to protect that client secret in the coming slides in the public client type. So here we see the scope. So as I mentioned earlier, the scope of the mechanism was limited the application access to the user account. So at the time of login, so the user will have the consenting page in the right hand side we are saying. So here we can see, so based on that application access, the application might needs these and all the scope. Scope is a kind of access permission. So we need to consent whether we can allow or cancel. So this is a simple OAuth scope. So basically, all the application will have a read, write, and full access scope will be there. So based on that scope selection, that application can only that selected scope permission only that application, third-party application can able to do on the application resource server. And we'll see the grant type here. The grant types is the flow, that what are the authorization process or flow we are going to use, the client application going to use in the communication with the OAuth service. So here we have a authorization code, and then authorization code with the PKCE. The PKCE is a proof key of a code exchange, and client credential and device code and reference code. So we'll see what is authorization code flow. So the authorization code grant type is used for confidential public client to exchange authorization code for access token. So here in this flow, that client application will directly access the authorization server and then get that authorization code, and then it with the authorization code it can get that access token. So this is a kind of here it involves a redirection URL that after that user logins. So in the redirection URL, the application will get that authorization code, and then with that authorization code, it can request for the access token. So here this way of authorization code flow is safer in that confidential client. In the public client, we need to ensure that we should use a PKCE mode. On top of authorization, we need to use the PKCE to extension to protect that authorization flow from prevention from CSR attack and authorization code injection attack. So we'll see. So what are those? What is PKCE flow in the latest slide? So this client credential type is used by the client to obtain the access token outside context. It's a kind of application communication. If you have a application to application communication, there is no that the user can't able to have that redirection and all on to work. So here what we'll do, we'll use as plain users access we'll get that access token for that users credential, direct credentials, and then it's mostly used in app to app communication, and device code is grant type is used for browserless or input constraint device like IoT device, smart TV, and digital service. There it has each device has its own device code. So through the device code, it can able to authenticate and get that access token. So that is mostly used in IoT device, and refresh token is used for client exchange. Here it uses a refresh token to get that access token. So in the sense, the refresh token is long lived and access token is short lived. So once that we got that in the first authorization redirection, we'll get that refresh token and access token. Once that access token expires, with that refresh token, we can able to get that access token. So we don't want to do that again. We don't want to do the authorization flow. We don't want to do. So with the refresh token, that application, third party application can able to do access that resource server. So here, this is the OAuth Flow with PKCE. So in normal, we have a four identity will be the user, client, authorization server, and API, app service API. So first the users clicks, once the first users click on the link. So this is a starting time. So if you want a client application want to access that any of that resource, it needs to click the link, and it checks whether it has that whether the request is having the access token. If the access token is not there, it redirect to the login page, and then in the login page, at the time of login page, the client generates a code verifier and the challenge. Code verifier is simply a random string, and challenge is the hash of that random string. And then it sends this the request, that request for authorization code. It sends a challenge with the challenge. So the authorization server will maintain the challenge in the server, in the authorization server side, and it returns redirects that to the login and authorization prompt. And then the user authenticate and consent, give the consenting. And once the authorization server gets that consenting response, it just sends that authorization code to that client. Now the client has to send that authorization code and the verifier. So the verifier is a random string, and the authorization server now validate the verifier, the random string, and then the code challenge. It's a hash. It has that verifier and check whether the previously sent challenge is equal or matching. If it is match, then it returns a ID token and the access token, and then the client, now the client can use the access token to get the request for the API service, and it can get the response. So here the main PKCE, what it does is it generates a code verifier and the code challenge, and it's injected that code challenge as part of this authorization workflow. So that in the redirection, how it benefits is in that in that browser as well as the mobile application. If any of that third-party browser extension, or if any third-party application tries to get the redirection URL, it can't able to get the access token, because those applications don't have the code. It won't have the code verifier. Since that authorization server will only respond with the valid verifier, code verifier, then only it can able to get that access token. So that it's much more production in OAuth or Flow. Thank you.